Hello everyone and welcome to the second part of the services unit, services in ROS. So in the first part you saw how to call a service, how to perform a call to a service, both using the command line with the ROS service call command, yes, and using Python code. But we need now to see the other side of services, so how to provide a service, how to give a service. So this is what we are going to see in this part 2 of services, how to provide a service for anyone to call it, yes? So, well, let's start with this example 3.7. We are going to execute this piece of Python code. So yeah, let's execute this piece of Python code. There we are. Excellent. So, well, apparently nothing happens, right? Nothing happens in the simulation, any message appearing anywhere. So what's going on? What do you think is happening? Why nothing is happening? Yeah, exactly. That's because we need to call the service. So now, by executing this piece of code, what we are doing is to start the service, make it available for anyone to call it. But if we want something to happen, if we want to execute the functionality of this service, we need to call it, right? Well, so that's what we are going to do right now. So let's use the ROS service call command. Then we need to put the name of the service, which in this case, it's, let me tell you, it's my service. We are going to check now this code, so don't worry. Then the name of the service is my service, and then if we do a double tap, it auto completes the message. In this case, it is an empty message, so nothing to put here, nothing to write here. So let's do a call to our service, and as you can see, it has appeared here, this message, my callback has been called. So this would be the response of the service. Yes, so it has printed here this string. This my callback has been called, which is stated here in this print. Great. So yeah, let's have a look at this code here to see what happened. You will see it's a very simple code. So, well, we'll stop this code. Okay. Excellent. So first of all, we have we import ROSPy as always. Then we import the type of message that we will be using. In this case, it's empty and empty response. So we are using the empty service message. Yes. Then we are defining a callback function, which contains a print. The print we saw here contains a print, and it returns an empty response, so it returns nothing else. It just does a print and it returns nothing. So in this case, the response is empty. Yes, we just have this print here. All right, then yeah, we are creating a node first of all here. In the main code, we start a node which is called service server. Then we create the service with this rospy.service. We specify the name of the service, which it was, in this case, my service. Yes, remember how we called it. So you specify, when creating the service, the name of the service, the name of the message this service will use, and a callback function. So when someone calls this service, this my callback function, which is this one, will be activated. Yeah. So when we executed this command here, the ROS service call my service, what we did was to activate this my callback function. So this print was printed here. Yes. And then finally, we add at the end a ROSPy spin in order to keep this service up until someone stops this code. This service will be up and available for anyone to call it. Yeah, so that's why we add here the ROSPy spin. So as you can see, it's very, very simple. So we initiate a node, we create the service, specify service name, message, and the callback function to activate on ROS BASICS pin, and then we just have to define our callback function, which is actually the functionality of the service, what this service will do when it's called. So inside here you could put anything. You could put to move the robot, to take a picture, whatever. In this case it's an example, so it just contains a print. Yes? Excellent. So we are going to start directly with an exercise. Yes. So yeah, let's read it a little bit. So the objective of this exercise is to create a service that, when called, BB-8 robot moves in a square-like trajectory. Yeah. So when we call this service, BB-8 robot will have to move in a square-like trajectory, so something like this. Here, here, and here. Yeah. Then create a Python file that has a class inside that allows the movement of the BB-8 in a square. This class could be called, for reference, move BB-8, and the Python code that contains it could be called moveBB8.py. To move BB-8, you just have to write into the command belt topic, as you did with the Copy robot. Yeah, so you, by writing a twist message into the command belt topic, you will be able to move the BB-8 robot. Yeah. Has inertia, of course, friction. Okay, yeah. So add a service server that accepts an empty service message and activates the square movement. So like this one, we will use the empty message in this case. Yes, in order to activate this service. So like this one. Then this service could be called moveBB8 in square, for instance, and this activation will be done through a call to the class that you just have generated, called moveBB8. So yeah, the class you created here in order to move the robot will be activated. Then yeah, for this you will need to create a very similar file as this one, as the example file we just saw, this example Python code. Yeah, it would be something similar, quite similar. Yeah. Then create a launch file, of course, in order to start everything. So yeah, launch this launch file that will start your service server, and try to call it try to activate it using this ROS service call. Yeah, so you will start your service server and you will test it using this ROS service call with the command line. Yes. Then after this, you will have to create another Python code containing a service client. So instead of calling it through the command line, you will call it through code, like you did in part 1 of services. Yeah, so you have to create a code to call your service that moves the BB-8 robot in a square. Then finally, you have to create another launch file that does everything. So first starts your service server and then calls that service. Yeah. So it will, yeah, you will have to include your first launch file that starts your service server, and then you have to launch your service client in order to call this service. So by executing this final launch file, your robot will start performing this square-like trajectory. Yes? Understood? Well, anyways, if you have any doubt, or if you get stuck, you don't know how to proceed, as always, you can have a look here at the solutions notebook in order to at least guide you a little bit with the exercise, but I suggest you to try to do it yourself. I think at this point you can do everything that we are asking you, so yeah, try to do it, and in any case, if you get too stuck, have a look here at the solutions. All right? Excellent. So now, until this point, we have been using service messages that were already provided. Yes, like this empty message. We saw in the part 1 the delete model, the exec trash messages. But what happens if you want to use a custom message, a custom service message? Okay, so let's see how we would do this. Yeah, in this case, I will do this with you. So yeah, just follow me and I will be explaining what I'm doing. All right, so the first step is to go to our workspace and we are going to create a new package, which let's call my custom service message package, like it is stated here. I will add as dependency ROS by. Excellent. So yeah, I've created the package. It will appear here right now. So now the next thing is to create a service folder in order to place our service message file. So let's create a new folder which will be called SRV and will contain the service message. Yes. Then inside here, I'm going to create a new file which I will call my custom service message.srv. Yes. Then inside here, we'll place this data. There we are. So let's maximize this. So our service message will contain two variables in the request, which will be a float called radius and an integer called repetitions. And as a response, it will have one variable called success, which will be a Boolean. Yes? So for calling our service, we will have to provide two arguments, the radius and repetitions. And when our service finishes, it will return a bool, saying true or false. Yes, understood? Excellent, so let's save our service message file. Then now, this is quite similar to how you created a custom message in Topics. So now we have to modify the CMake lists.txt file and the package.xml file. Yes, so yeah, let's start with the CMake lists. So let's open our CMake lists file. I'm going to make my ID bigger now. Excellent. All right, so I will search this find package function, which is, I think it's right here. Okay, so inside here I will need to add standard messages and message generation. Yes, these two. Because these two packages, I will need them in order to compile my new message. Yeah, so I will add them here at the find package function, as it is explained here. So then now I will find for the search the add service files, which is here, and here I will have to obviously state my service file, which in my case it's called my custom service message. There we have it. So it's my custom service message.srv. Yes, there we have it, my custom service message.srv. Excellent. So that's it in this function. Then the next function we will need to modify is the generate messages function. So let's find, okay, there we have it. Here we have it, generate messages. So let's uncomment this function as well. And in this case, we don't need to modify anything. So we just need to uncomment it in order to activate it, because this is just like I want it to be, like it is shown here. So in this case, I will not add anything. I just uncomment it to activate it. And finally, I will need to go to the catkin package function. Let's find it as well. Catkin package. No. Let's see. Okay, it is this one, yeah. So in this function, catkin package, I will need to comment the catkin dependencies ROS by, which is this line here. Yes. And yeah, that's it. I have it now like this. So yeah, that's all for the CMake lists txt file modifications. So I'll make sure to save this file, and then let's move to the package XML, which we'll have to make some modifications as well. In this case, we need to add this message generation and message runtime as build depend and run depend. So let's copy this here. There we are. So as build depend, I will add message generation, and as run depend, I will add message runtime. Excellent. So I save as well this file, and yeah, that's all. I have done the proper modifications. So let me switch back to this mode. So now what I will do is to compile my package catkin make. Let's compile this and see if everything goes okay. We'll have to wait a few moments until it compiles. There we are. Okay, so apparently it's going fine. It's generating my messages. Yeah, so apparently everything went okay. So now, remember, you need to source your workspace in any web shell you want to use this message. So in this case, I will work in this web shell, so I will source this one, but if I move to this web shell later, I will have to do the same, source devel setup.bash, and the same for any work shell I want to work with, and use this new message, of course. Excellent. So yeah, let me execute this command here a moment to see if everything went okay. So here I will get a list of all the service messages, and I will filter for my custom service message name, which is the name of my message. So here I can see that apparently my message is detected, yeah, my custom service message in my custom service message package, which is this one here. So yeah, it looks good. So now I'm going to do a ROS service show as well to make sure that my package is well defined. My custom service, let's see. Excellent. So as you can see, here it is my the definition of my message with the radius, repetitions, and success, as you can see here. Okay, so yeah, apparently everything went fine. Excellent. So we have created our custom message. Perfect. So now let's use it. So yeah, for that, let's move to exercise 3.3. And here we will have to use our new message in order to apply it in a service, yes. So as it says upgrade the Python file moveBB8.py, which you created in the previous exercise, so that it can move BB8 in a square of variable size. So in the exercise you did previously, you moved in a square which was always the same size, yes? So now you have to modify a little bit this code in order to be able to modify the size of that square, yes? And that will be depending on the value of this radius float, yes? So if you specify here 2, the square will be one size. If you specify the radius 5, the square will have to be bigger. Yes, you understand the idea? Excellent. So then create a new Python file called bb8move custom service server.py, okay? Modifying the service that accepts an empty service message and activates the square movement that you created in the previous exercise. This new service could be called whatever, and this new service will have to use the service message of type bb8 custom service message. Okay, in this case, you can use, okay, yeah, here it is defined a new message which uses a side variable instead of radius, but if you want you can use this one because it's almost the same, as you can see. The only thing that is different is the name of this variable. So you can use this my custom service message for this exercise. There's no problem on that, yes? Then you will have to, yeah, we'll summarize this basically. So you will have to modify the code in the previous exercise so that you accept these two arguments, radius and repetitions. And based on the radius, you will have to make this square bigger or smaller. And based on the repetitions, you will do this square movement 1 time, 2 times, 3 times, whatever the value is in this repetitions argument. Yes? So you will have to take into account these two arguments, the radius of the square and the number of repetitions BB8 will do. Yes? And finally, you will return the success boolean as a response when the service finishes. Yes? As always, try to do it yourself, try to solve it yourself. Even if you have problems, keep pushing, try to solve them, because this is the way you will learn more. And if, despite you try it, you cannot advance, you cannot solve it, you can also check here the solutions for this exercise, possible solutions for this exercise. Okay, so try to solve it yourself, try to do it, even if you struggle to solve it, try it, don't give up. And as a last resort, you can check here the solution of the exercise, okay, or at least take some hints, some advice on how you can proceed. And yeah, and that's all for this second part of the services unit. And well, I will see you in the next unit, where we will start with actions, so get ready.